All right. Let's begin. Welcome, everyone, to the last workshop, Cloud Month. I know that this isn't exactly cloud related, but we do have a purpose for this, and that will be explained at the end of this workshop. So, welcome to our first and also beginner Python workshop with Tom Frantz. So, I will let Tom actually introduce himself and take you guys through in this journey.
Hello everyone. So I'm Tom. Nice to meet you all. I'll be doing this Python workshop. So a little bit about me. I studied at RMIT for 3 years, from 2018 to the end of 2020, and I graduated. And now I'm working at Leidos, so Melbourne-based company. I'm a graduate software engineer, and I've been working there since February. Python is one of, if not my absolute favorite language. I've been learning Python since I think about grade 5 or grade 6. My dad showed me how to do times tables on it, and I've been hooked ever since. So I've been programming, I guess, properly in Python since year 9, year 10-ish. So I've learned quite a bit of it, and hopefully I'll be able to show you guys a little bit about it all. Alrighty. So if you check chat, I've just put a link in for the Python downloads, but if you want to grab it from here, I'll give you just a moment. You're more than welcome to follow along, but it's not required. So everything I'm going to be showing will be easily replicatable. And if you do download it, feel free to open it up. There should be a program called Idle, spelled IDLE. For Python, and if you open that up, it will give you this window where you can enter commands like this, for example. There we go. Good first start with a live demo. So yeah, I'll give you guys just a moment to do that. Well, yeah. If anyone's got any questions about what we're going to be covering or anything like that, now's a good time to ask if there's anything that you want to know before you get started, I guess. So I'll just give you guys a moment to do that.
I think Brian has a question. Brian? So he's asking if you can explain object-oriented.
Yeah, so in Python, object-oriented programming, or OOP, is just a way of using programming through classes and instances of classes to organize your code. So Python has full support for that. It also has a lot of functional programming idioms, so you can use maps, reducers, that sort of things, and a few other different things that are sort of less mainstream, sort of more in the past. I think it has a little bit of imperative stuff through it as well. Generics is actually an interesting question for Python, because Python doesn't have generics. I'll probably touch more of it on the end, Andrew, but since Python is dynamically typed, you don't actually need to worry about types for type in functions. And Jessica, that is a good question. Python is my favorite language because it is really simple, really easy to read, and super fast to program. Like, just a fun fact that I know is the first iteration of Google, like the Google search engine, was actually written in Python because it was really easy to prototype, really easy to get out there. Other big things like YouTube backend, Instagram, I think, and Dropbox. All of those are all written in Python as well. So again, really fast to develop in, really easy to develop in, and whether that's 2 people to 2,000 people. So yeah. Anyway, so yeah, I guess we'll get started. Jumping in to something really easy. Hello world. So I'm sure you've all seen how to do this in other languages before. If you're brand new to programming, this is how we get stuff out in the console. So I've done it just here as well. If you type this set of characters, I guess, and you run it, Python will print out stuff for you, which is pretty cool. This is sort of foundational level for all programming yeah, here it is in Python. The standard way to do output is this method, print, right here. So there's sort of like 3 parts to this sort of thing. This is probably a lot basic if you've done any sort of programming before, but for anyone who's completely new in the chat, you can see here, there's the name of the function that we're calling. So in this case, it's print. So this is basically letting us know what it's going to do. In this case, it's going to print out to our console. There's brackets, which are used to specify parameters, which is basically, in this case, it's saying everything in between the brackets is what we want to print out. And then finally, we have the string hello world, which is, just a set of text that says hello world. And that gets passed to print, and then print says, oh, we have this text, let's print it out to the console. So that's a super basic introduction to like the most fundamental parts of Python, a little bit of output, and a few different parts of it. So yeah. Going forward, it's a little bit more input and output. Again, here we still have print as before, but we've got some other things happening here as well. So just jumping straight in, we've got this name equals on an input with a whole bunch of extra stuff. But if we actually look here, name is important because this is the first time we're using a variable. In Python, you don't need to specify the type of the variable if you're coming from something like Java or C. If you're coming from JavaScript, you don't need a const or a var or a let or anything like that. In Python, to store something as a variable, to use that later, all you need to do is just the variable name equals. And it follows some pretty standard rules like, no numbers in front of it, using underscores, that sort of thing. Yeah, so that's a little bit of a jump start on variables. If we're having a look at what's next, there's sort of this input name. So like print from before, where that was the name of like printing out to the console. Input is getting user feedback from the console. So if we open this up and we type it in input, let's say name equals, what is your name? We put a space on the end because it prints that out. That's the message it asks you for. And then you can put in your name. So my name's Tom. And then if I check out name, like down below, oops, there we go. I forgot a plus. After a rocket start, you can see there that it prints out our name from this bit here. Going back to these slides, whoops, one too far. You can see that right there. Our name gets captured from our inputs. Whatever you type in, it can be anything. It can be your actual name. It could not be your actual name. It could be your favorite food, whatever you want to put in there. Will get stored in this variable called name. And then when we go down here and print, we can just chuck it in here using these plus symbols and these quotes to show if it's just a string, and no quotes if it's a variable, and then quotes again if it's a string. Yeah. How did you? Oh, no, I didn't copy paste it. I think what I did was if you go up and hit enter, it will copy paste the line down for you. So that's quick little trick if you're following along. You can do enter, and you can also do copy paste. So if I do copy by Control C and I Control V, as you can see, that's pretty simple as well. And if you type garbage in and you just want to get rid of it, if you do Control C, it'll do a keyboard interrupt and give you a new line. I hope that helps, Brian. For everyone following along, if you've got any questions when you're trying to do this stuff as well, feel free to ask out. If I'm going too slow or too fast as well, please just shout. But yeah, so there's a sort of jump start into getting input and output. I sort of skimmed over a little bit over the pluses and the quotes. I'm expecting most people will have some level of programming background since you've just done a month of cloud. Yes, Andrew, good question. Andrew's just asking how are statements and expressions terminated. In Python, that is a new line character. So you just hit enter and it terminates automatically for you. It's actually a good point to make. Python is sensitive to white space. So if you have an extra space here, the Python program will not cooperate nicely. I don't believe I can show it here. Oh, it will. Yeah. So just because I have some extra spaces, it does not have a good time. So that is something to keep in mind. Spaces at the start of a line are very sensitive, and then it terminates with a new line as well, or whenever you hit enter. So yeah. Moving forward, so we talked a little bit just before about variables. In this case, I'm just going to show you a few more. Again, sort of assuming that everyone here is pretty comfortable with these sort of practices. So if you're not, and you want me to slow down and go over this a bit more in detail, please do say so in the chat. But otherwise, from now on, I think I'm just going to go ahead, assuming that everyone's done a semester or so of computer science. Python again, so all of these parts here, you can see there's no type, there's no const, there's no nothing. It's just a variable name and then assigning through an equals. And here's some, there's some examples of some names. You can have underscores and numbers as long as they're not at the start. You can have underscores at the start, but not numbers. And it's typically used in Python that you use underscores as spaces compared to camel case. Here's some different data types as well. So strings can be used with double quotes or single quotes. You're just going to match them up. Numbers and decimals are all just as they are. So if we pull this up real quick, we can do print 21 like that, and I'll print that, or print 21.111, and that handles all that for you as well. And if we do plus, I'll take 2. That, for example, we can see it does floating points seamlessly between integers and doubles and all that sort of stuff. So you don't have to worry about the types, it just handles it all, which is another super neat thing I love about Python. It just does all this hard stuff for you. True and false might catch a lot of people up. If you have troubles with true and false, double check your capitalization, because unlike a lot of other languages, Python does it through with capitals for true and false, and same thing for null, or in Python's case, it calls it none. So yeah, it's all just a bunch of little things designed to sort of catch you up. Now, you might not be used to them, but it's good to just be aware that Python does things in a slightly different way. Going forward, so operators and maths, pretty stock standard. If you're coming from JavaScript, welcome back to the real world. It's no more of this triple equals nonsense. Here's some pretty stock standard ones. You got your double equals, you got your not equals, less than, greater than, less than or greater than. All of these will evaluate to true. And then moving forward, same thing for maths. Plus, minus, times is star, divide is slash. But Python also comes natively with a double star, which is 2 to the power of 3 or x to the power of y. Which I think is a super neat thing to have. Again, there's a lot of really cool little things in Python that sort of carry through. And yeah, it's sort of just finding them and being aware of them makes everything a little bit easier. It saves a lot of typing when you don't have to do math.pow or whatever it is in other languages. Python is also a language that allows you to type straight English most of the time, which is really cool. So you don't need to use things like double ampersands or double the line thingy, I don't know what it's called, or contains or all that sort of stuff. I've actually missed one here, in, which is a really powerful one. But you can see here, if you want to do like something and something, or something or something, or something is something, or any of those sort of things, you can just use the words and, or, is, not. And the one I missed was in. So you can actually do something like this. If we wanted to check if Millie is in a list of me and Millie, what else we can put in? Junior and Wednesday.
Junior.
Wednesday. We can see that will give us true. But if we take Millie out of that list, you can see that that is not the case. But there's a whole bunch of really cool things that allow you to do a bunch of really easy things. And Java, I think this is list.contains, and then you have to put it in there. And it's really finicky with nulls and a whole bunch of other things, probably. So yeah, again, is in an iterator. It's a good way to think of it like that, Andrew. I'm pretty sure it is mostly under the hood. You can also use it for things like dictionaries. So if we had, or I'll come back to this one a bit later, but yeah, it basically is. It's a good way. We'll sort of search through the list or the dictionary or anything iterable and see if it matches any of those items in that list. Yeah, so we can use other things like true, and true will obviously give us true back, but if we do true and false, that will be that as well. Another interesting thing to note is not can be appended to basically anything of these. So you can do and not, or odd not, or is not, or not in as well. So if we do something like Millie is not in this, I believe that will also not in that will give us exactly what we expect. So that's another really cool thing is you can pretty much write any sort of conditionals using these 5 words, and it makes everything so much more easy to read. But speaking of conditions, we are going to move forward a bit and go forward. I'm still getting used to presentations apparently. To control flow. So this is your if conditions, your else conditions, your else if conditions, all of these sort of things. Python has a pretty standard way of handling all of these structures, including functions, for loops, while loops, classes, anything nested like this, all works in a very similar way. So if we try and dissect this is sort of like the structure, the foundation of an if statement, where you have the if keyword, followed by a condition. So this is something like that we were just showing, with Millie not in this list. And then there's an indentation followed by your code. So if we have a look, I also forgot to mention, luckily I have this slide here for me, where there is also, it's after the condition terminates, it's followed by a colon to indicate that that's the end of the condition, and then and there's an indentation that follows that shows it's the start of the code that's supposed to be executing. So you can see how this matches up in an actual code example down here. Moving forward, we can see this condition can just be anything like this. So name equals Tom, or you can do name is Tom, name is not Tom, anything like that, that will all work. And then moving forward, we have the code here as well. So all of this looks pretty easy. You're probably wondering why I have this gap. I mentioned this indentation before, and that's basically because, as I said, I think way at the start, Python is really sensitive to these spaces up front. By default, Python, I think you can change this. I'm not sure if you can or can't, but by default, Python calls a level of indentation as 4 spaces. So underneath this if condition, it will only recognize valid code if it starts with 4 spaces. And the reason that is if we open this and we do if true, just so it will evaluate, and then we do, in this it does 8 spaces because it's weird, but it should be 4. If true, then we do print. Excuse me, I just hit enter. Print this. And then we tab back out to the start and print. That's not gonna play nice because it's inside this, but if we do this, we'll see whether that works. Probably can show it if I do this real quick. So I'm just gonna open up a little script. So good way of thinking about this, so I've got to include comments, is something like this. If you're coming from a JavaScript or basically any other language background, this is sort of the syntax that sort of gets implied by those bits of white space. So if we run this module, let me just save it. We can see this code will run and then this code will run as we sort of expected it would be. But if we made this condition equate to something false, and we run that again, we can see that it will only run the one outside the condition because that's when it starts resuming its normal flow of execution. So that's a sort of quick but a fairly important part of Python, is everything under these control flow statements. When it's indented, it means that it falls under that, like as if you would put it inside the brackets, and then once it outdents again, that means it's back to the regular flow. So it's as if it was never inside the brackets in the first place. Moving on. So this again is a sort of another fairly straightforward example. Again, if you're coming from a programming background, if, else if, or else conditions. So you can see here, if the name is Tom, print hi Tom. Else if, this short abbreviation stands for else if. The name equals Millie, then print hi Millie. Otherwise, the else statement, print hi stranger. And this follows the same set of rules as it does anywhere else, with the 4 spaces indentation, just here and here. So yeah, that's rushing through that. Everyone okay? No questions, nothing like that? All right, I think we're going good. Feel free to ask. I don't bite. But continuing on into the next part. So this is sort of where it gets a little bit more tricky. This is using some more advanced data types like lists and dictionaries, which we'll be covering next. But here's a good example of lists. Basically here, we define the list on this line right here. So it's a list of my favorite foods: salmon, prawn pasta, and this pizza variable. So we can see this doesn't have the quotes. So it actually refers to this variable above it here. We can see, this Leonardo's Meat Lover Pizza, best pizza in the world, really good. Unfortunately, they're closed right now, but when they come back, I would recommend everyone go try it. Really nice. We can see that this list will equate to salmon, and then prawns pasta will be the second item, and the third and last item will be Leonardo's Meat Lovers Pizza. And then if you want to get data out of a list, again, this shouldn't be anything new to everyone else, or to everyone who's here. You just use square brackets and then the number starting from 0. So salmon would be 0, prawn pasta is 1, and then pizza is 2. To get that value out. So if we did fav foods, which is the name of the variable, square brackets 1, which is 0, 1, we'd get out prawn pasta. It's probably good again to sort of experiment with this if you're a bit uncomfortable with it. I don't know if Java has a super easy way to get things out, but in Python, pretty much most data access and retrievals will be done through this level mechanism. But yeah, now that we sort of got an understanding of lists, there's a good question. Andrew just asked list difference to arrays. I believe that they work, lists are basically arrays in Python, but there's no standard sort of shorthand syntax for any other types of lists. So I believe there's collections for like linked lists or other sort of types, but most things under the hood will just use the default array in Python. It's pretty often, I think it's called vectors in C or like that, but it's pretty often that this sort of vector arrays list sort of structure is pretty much the de facto go-to in any sort of programming. So yeah. So there's some slight differences between different data types depending on how they're implemented, but yeah, this is pretty much just your vector / array list style. Moving forward onto loops. So this is a while loop. This one works very similarly to the if statement, except it bases off this condition. So in this situation, we can say we print this is a dream and then while true. So that condition will never change. It will always just keep iterating over and over. It will jump in here and then it'll see it's true and do it again and do it again and do it again. So we end up in a lot of dreams. But if we have a look and we open up IDE and we write something like this, x equals 0, while x is less than 10, print x is plus. There's also plus equals, or you can use equals. I forgot to mention plus equals, but that will work. If we run this, it should run all the way from 0 all the way up to 9, and then not proceed to print 10 since we're using less than. Just like that. So yeah, that's basically how you would write an while loop. And the same sort of thing carries forward in all other sort of loops, where it's just this sort of thing again. While condition, do this. There's no concept of a do while. I think C has that. I'm not sure if Java does. Pretty much this is just the main sort of while loop. And yeah. Continuing on, we also have for loops. So for loops in Python are quite powerful. You can do a lot of things with for loops. You can put lists in there. You can put dictionaries or hash maps, also commonly known. You can put basically anything in there, as long as you've implemented the right method. But that's probably a more advanced topic. I'd be more than happy to talk about it because it's one of my favorite features of Python. But in this example, I've got just the skeleton up here again for item in iterator, and then some code down here to sort of explain how that looks. So for food in this list of pizza, pasta, and garlic bread, print I love and then that food. So this is sneaking a little bit of fun syntax right here. Python has some really cool stuff, and I will quickly just go ahead and demo this. That's not the right one, that's the one we want. So if we go here, for food. Again, these for loops and while loops, they also have the same structure of keyword at the start, followed by the colon at the end. So that's good to know. Most things will follow that structure if you're indenting into a new line. So this f string, you can see that works pretty much just as expected. This sort of will iterate through each item, not the index value, but the actual value, and extract that out. And then this f string, what it does is if you precede a string with an f, and then use these curly braces, you can actually just put in straight variables that you have from outside of the string. So if we did something like we can see, that is the value of x now, after this loop had just completed. Yep. So I'm just going to quickly terminate this. so I can keep getting notifications. But yes, moving forward. This is the same sort of thing as before, but now it's slightly more complicated. So I've added in this conditional, and we can see here that we have a section where we have 2 indents. So now this is, instead of 4 spaces, it will be 8 spaces. And then it also has this keyword here, this break. I just saw Jack's question. I'll get back to that in just a sec. But what break allows you to do is exit the loop early. So if I go ahead and write this code in here, for food in computer Args. Let's try it here. Let's see what this one does. So going back to your question now, Jack, the F stands for, it's like a format string. I believe it's just commonly known as an F string in Python. And what that allows you to do is use these curly brackets to access variables outside of the string. So in this case, we wouldn't, if we just typed food like this, it wouldn't be anything, it would just print food. But if we chuck these curly brackets around it, while we've got that F in the front, it will be actually equal to whatever this food is here. So in the first time through the loop, it will be equal to pasta, so it'll print pasta. Or the second time through the loop, when food is equal to grass, and this condition is true, it will then actually go here and print F, and then this will be grass. So, doing that. This is using break. And that's the end of our loop. So we can see what happens is the first time through it goes for food in this list, grabs the first element. If food is grass, which pizza is not grass, it will skip this section and print this, and then go back around to the top, and it gets the next item, which in this case is grass. Goes here, food, grass is grass, controversial, I know, and then goes here, prints this statement as we'd expect, and then breaks. And what break does, instead of continuing on with the rest of this, it basically just exits the for loops and then continues with whatever code we would have underneath it at this level of indentation. So it doesn't do anything more inside the for loop. So, any questions about that? Printf. Okay, so GDSC RMIT University just asked me. I didn't know a whole university could ask me. But in Python, there's actually, I don't think there's a printf. So if we look at print, we can see that that's the built-in function. But if we do printf, there is no such thing as printf. The only way you can print stuff out in Python is through this print method. But if you have a look here, here's this. We can see that print takes a whole bunch of other things. This is a bit more advanced, don't worry about it too much. That allows you to sort of emulate extra functionality in the print. But it all just goes through this. I'm going to quickly move forward so nobody gets confused by that, because that's a bit of advanced stuff in Python. I'd be more than happy to talk about that. All right, Michael just asked a good question about is and the double equals, and there is an interesting thing there. So if I do x equals 1 here and y equals 1, we can see that x is equal to, whoop, I don't know what I clicked to do that. That is interesting. X and y, they should be equal, I think. This is going to be live demo territory, so who knows, but they're true. But if we do x is y, they're actually different arrays. So I think, I don't know how it works under the hood, but basically if they're pointing to the same, the actual same item, so in this case, the same array, so x is x, or if we do z equals x, like that, and z, then they'll be true. But if they point to different things, so z is y, so they're pointing to the two different arrays, yeah, like memory addresses. Pame, not exactly, but sort of. But yeah, Pamal I think is pretty much spot on. It's basically the concept of like, is it the same piece of memory compared to does it have the same value? So I was a bit cheeky. I was chucking in is. That shouldn't work by what I just said, but what Python does is, so if we do the same thing again, where we say x equals 1 and y equals 1, and we'd expect now if we do x is y, that should be false, right? Because they're different ones. We assign them to be different ones. But in reality, it's true. Because the strings and numbers and booleans and none, so true and false and none, it actually doesn't compare their memory, it compares them by value. So it's a little bit tricky with the finer details of it, but for strings and numbers, they are interchangeable. For everything, strings, numbers, booleans, and the null value, they are interchangeable, but everything else is not interchangeable. Double equals or the equivalence operator and is will give you different results, but depending on what you want to do. Andrew H, yes, you can definitely do that. That was just me being cheeky because I like doing F strings. I wanted to show something cool. But yeah, also Elizabeth, thank you for showing that. Exactly. You can use triple strings, multi-line, like that, and if we see, that would give us one new line, multi, another new line, line, and then another new line. That's a lot of lines before the final termination. So yeah, you can use multi-strings. This also works straight for variables, so if we do something like multi, we can see that will also just work straight there, which is another really cool feature of Python that's very underappreciated. In other languages, you'll have to do plus on the end of everything or other things like that. I'm pretty sure most, like Java, I'm not sure if JavaScript's nice, but a lot of things get up in arms about that. Python, you can just do that, which is super helpful. Very, very, very helpful. But yeah, I think that's everyone's questions covered. Jack, just to double check, yes, hash is also a comment, so that does nothing. Yeah, it's everything after the comment as well, as you would expect. There's no such. I don't think you can do this if we did print hello. I'll give you a default syntax because it doesn't read as a comment; it reads as a string literal. So that's just good to know as well. But yeah. I think that's covered everything about that. Yep, that the F-string stuff will probably come up again, but yeah, again, it's just me being cheeky and not wanting to put pluses in all the time. But yeah, any more questions about for loops, while loops before we move ahead? All right, I'll take that as a no and keep going. And on to one of the coolest parts of Python, in my opinion, especially if you're coming from JavaScript, a similar sort of thing, but dictionaries. If you're coming from a Java background, which I think first years are these days, I'm not sure what you learn much at RMIT anymore, or even a C background, these dictionaries will blow your mind. They're really fun. Really, really good fun. Basically here, I've just got a little code snippet about how dictionaries work. So, but just here, this is the guts of it. This is how a dictionary is sort of done in short, where we have key value pairs. So we have like, a key of name or age or siblings, and then the values over here. And that's all just done. Yeah. Thanks, Millie, for pointing that out. But yeah, if you want to store key value pairs, you can use these curly brackets and then put all of them in here. So that's really good if you need literally like a dictionary and look up something to get something else. So you're like, what does this word mean? You open a dictionary and you look for it, and then you see there's the key or the name of the actual word, and then there's the value or the explanation of the word after. So in this case, me, that's the name of the dictionary. You know, my name is this value of my name. So name is my name, which is Tom. My age is 21, and I have one sibling. Yeah, and you can see, you know, using variables inside dictionaries is really easy. You could put I could just put Tom straight in here, make it a little bit cleaner, but, you know, just want to show that. You know, and you can also get it out exactly the same way that you would an array. You would just do this. The name of the dictionary or the array, the square brackets, and then you just put in the string of the key that you want to get the value out of. So if we go ahead and run this, I'll pull this up. That's the wrong one. I'll close that for now. So I'm going to keep pulling it up. And we'll just make this a slight tad smaller. So we can, yeah, let's just put that right there. So if we do something like this, we'll do A equals name. These will have to go in quotes. Unfortunately, you can't have them freestanding, so they're going to be like that, I believe. From I've been cheeky. I've forgotten commas in this. I will have to fix that up. But yes, you need to follow along with the commas after each key. So name, age, Paul, very close. List is, yeah, again, just the index, the 0, 1, 2, so on. You can also use negatives, but that's a little bit more advanced. I would suggest looking that up if you think, if you want to learn that. But the dictionary is exactly like age, except you need to make sure it's a string. So do this real quick. And then if I go me, age. So what you've written out is without these quotes. And if we do that, we'll see that gives me an error because age isn't defined. And then if we go through and do this again, but we put in the quotes, we'll see that it will match that key properly and give me that value back. Michael just asked, what is the command to remove variable values? I believe that is del. That's a keyword. You don't need to use it too often. Python is garbage collected, so you don't have to worry about manually deleting memory. It does it through reference counting, so it's relatively decent. It will do loops, but if you wanted to get rid of something, you can do del. And me, for example, if we do me, it will give us an error saying that me is not being defined. It doesn't have a value. So if we go back just real quickly and put that back in, we see if we do me, it's name and age. And then you can also use this for keys. So if we do me, whoops, and then again, we can see it's removed just the key value. Again, really straightforward. If you're doing anything like this in any other language, it can get very verbose. And, you know, it's a lot of function names. Whereas Python, you just use the keyword, pass in the thing you want to delete. It just basically figures it out for you. But yeah. Justin, I missed your question from before. You cannot actually use the JavaScript dot notation. So if I do something like this, that's what you're asking, it'll give us that. Me, if I do, then let's just get a syntax error. You can't do anything like that. The reason is because there's some stuff under the hood. It's pretty advanced how it works internally. If we have time at the end and you want to learn more about it, just ask me again and I'd be excited to explain. I love this sort of stuff. But yeah, continuing on, I've got a little bit here. Who was it that asked about this? Andrew H. Yes, I have mentioned this here, but you beat me to it. You've been keeping an eagle eye on it. But yeah, again, this is just this concept of using F and then these curly brackets to put any variable, even inside a dictionary, inside a list, wherever you want to, in here like this. Probably one good thing to mention is if we do this again, so we do me equals name. If you have nested values, so if we do something like this, right, we can do another nested dictionary, and then if I want to put my first, and there we go. If we wanted to get out my first name, for example, we could move me name, and then that would give us the dictionary inside its value. So all we have to do after that is we just basically concatenate straight on the end of your syntax, and that's how it works like that. So if you've got nested dictionaries, nested lists, nested dictionaries in lists, lists in dictionaries, it all works by that same sort of process. So if we go up here and we go put in all my real friends, why not? And then we do that. So if I wanted to do, it would be me, I wanted to get my friends, I'm going to do that straight like that. But if I wanted to get my first friend, best friend, some would say, we can just go straight there like that. And then that's just mixing up these sort of combinations. It'll work any which way combination you go. So that makes it really easy to go in and out of dictionaries, lists, and every which way around. Anyway, continuing on, functions. So we sort of covered through all of the conditionals, all of the all the conditionals, all the loops, so while loops, for loops. We covered through like break statements. We covered through dictionaries, variables, lists, operators. Is there anything indentation, input and output? So is there anything anyone sort of wants to ask about again before we get into functions and classes? The sort of the last two things that I want to talk about, a bit more complicated, but again, probably now is a good time to ask about any of those things we sort of just brushed through if you have any questions. Andrew, yes, it's not as strict as JSON, I believe. So in JSON, you can't have trailing comments, but if we do something like value but you wouldn't be able to do something like that in JSON, but in Python you can do that. It handles that. You can also use single quotes. So if I do this, that will also work just fine. In JSON, that wouldn't work. And then if you're using true or false or none, you'll have to be careful on the spelling, because in Python, again, they have different spellings to JSON. But I think everything else, off the top of my head, is basically exactly like JSON. So there's nothing stopping you from copying a huge blob of JSON straight in and basically just using it as a dictionary. You just need to make sure you cover all those little edge cases, which is super handy. Anyone else have any questions? I'll give it maybe one more minute just to see. Why do I need commas even for that single line? Oh, you don't need commas for that line. So if I go and do this, you can see it will work just the same. I was just showing that there because I'm in JSON or JavaScript oriented notation or JSON files. You can't put that trailing comma because it will throw an error. It doesn't like it, which is very silly, but it is just how it is. Anyway, moving forward, I guess. I don't think anyone else has any more questions. So going into functions. In Python, functions work pretty similarly again to everything else we've seen with like conditionals and for loops, where you have a name and then, oh, I don't have it here, but you have like a keyword followed by something in the middle followed by a column. And then everything that's inside the function, so everything that would be inside curly brackets here to here, is just tabbed in, as if you're formatting properly. The keyword for defining a function in Python is cleverly named def, that's short for define. And yeah, so you basically just use def, and then you put in your function name. So this can be anything. The convention is using snake case, which is these underscores and lowercase on both the start and any preceding word. So it's not used, you don't use camel case for this situation. And then you have a set of brackets followed by the parameters you want to pass in. So following on with like the trend that Python has been as a dynamically typed language, you don't need to specify types here. You don't need to say if they're strings or numbers. Some people don't like that. Some people love it. I'm sort of on the fence. The good thing about Python is you can put those in optionally. I don't know enough about that because I haven't written any of it. And a lot of that's inspired from TypeScript. If anyone here is a TypeScript wizard, you'll know that TypeScript's type language is quite good, or type system is quite good. And Python, Guido, the guy who actually made Python, took a huge amount of inspiration from how TypeScript did it when they implemented it. But yeah, continuing on, we also see here, like this is a quick little example of code. And then returning variables from a function, so you're passing stuff in, you want to get stuff out, you can use the return keyword or the yield keyword, but that's for generators and it's probably a bit more of a moderately to advanced topic. So I'll do a quick demo of this one as well, because this is a little bit more important. Beth. Oops. Here, we've just gone through and defined the function. One thing to note, if you're coming from Java, I think Java is the only one that will do this. If Java is the only language you programmed in, this probably looks really weird. You're probably asking me, why haven't I put this in a class? Functions in Python are first-class members, so they're just as well supported as classes or variables or any of the other data types that I've shown you today. And you don't need to put them in anything, they can just hang out as they are. So if we have a look at the variable say hello to, which is the name of this function, we can see it's a function that's named as this and it's living in memory at this location. Yeah, to call functions, we've seen it a couple times already. So when we've done print and input, which we've done a few times actually throughout all of this, you basically can call any of your own functions the same way. So you say hello to, and then so we're going to say hello to the GDSC lead itself. You can say hello Millie. Hi Millie. Yeah. You look very amused over there.
Oh, I am.
Yeah. But yes, it's just as you would expect it. You know, you just say, use those curly brackets and, yeah. Oh, not curly brackets, just the regular brackets, putting in variables and stuff like that. Something interesting about this is all, though, whoops, is if we copy this through and we get rid of this, I believe we can also do fun things like this. wonder if this will work. That will work. All these things have string representations, so you can just chuck them straight into an F string, and it just knows what to do. Which can maybe a little bit confusing, maybe good. I wonder if we can do this. Yep, you can do binary as well, or hex. I think that would be. Yep, there you are. Say hello to 255 for yourself. You can do all sorts of really weird things. That's something else you can do in Python that I forgot about. You can do 0x and then chuck in hexadecimal. So if anyone has favorite hex code, you can see the actual value of that hex code right there. Super useful if you're really interested in hex, but yeah. So one thing about Python is, though, since it is sensitive to indentation, if you just want to have a dummy function name or a dummy class or a dummy for loop with nothing actually inside of it, so if we did something like this, for I in range 100, which would get a range of 100, we can't actually just leave that. This isn't even going to let me do anything with it, but you know, if we open up a new file again and we do something like this, we'll do, right. Then we just do that, and then we go. I entertain myself far too much with this. But see how we've got this sort of floating space? You'd expect that there would be at least one line that's tabbed in and does something with that I, right? But in any other language, you know, if you chuck curly brackets like that, it would be fine. It, you know, it would just expect that that's an empty statement. But if we do this, we save it and we run it. We save it under example. It will give us a syntax error. It won't even let us run the file. So the way around this is, as I put here, is this pass statement. Another keyword in Python. So if we try and run this now, we can see here, pass just means do nothing. It means we know that we've just said this. We don't want to get rid of it. We just want to say do nothing. So one thing might be if, you know, some string with long condition, we might do something like pass, else, you know, that's not the best example, but maybe it's one of them. Or maybe you want to do there's some situations where you may want to have some sort of structure like a for loop, a function, a class, or something else that is just empty, doesn't have any code in it that it should execute. That's where you would use the pass statement. And you just put that on the correct level of indentation. So in this case, it's that level of full indentation. So I won't save that, but continuing on, that's Python functions. Pretty much in a nutshell. Pretty straightforward stuff. Does anyone have any questions, anything like that for this? Sort of really brush through them. I've sort of covered through the basics of parameters and things. We're running pretty ahead of schedule. Yes, Andrew, functions can return any type. So going back here, this value, again, there's no need to type the return type. You can, I believe, I don't know the exact syntax of it, but you can definitely do that with Python's optional typing, but it's not required. As a dynamic language, you don't need to worry about types in the code. It does it all at runtime. I guess I'll show you a quick example of did I spell that right? Oh, I think I just hit enter, my bad. a bit finicky. I have to do double enter, and then I can do. There we are. And you can see that concatenates. This might be a good time to have a slight segue, and let's try something like this. Here we are. So, while Python is dynamically typed, which means you don't have to specify types in the code, it is strongly typed. So, I think that's, I don't know if Java is strongly typed or weakly typed, but I know JavaScript is weakly typed. And what that means is if the types don't match and you can't do things with the two types. So for example, you can't, it doesn't know how to plus a number and a string. What happens is instead of trying to change the number into a string or the string into a number in a weakly typed system, that's what happens in JavaScript. If it doesn't know what one, if they don't work the same, it will change one into the other. But in Python, that's not the case, so it won't try and change a none or a number into the other. So I believe if we do this again, with a number, again, same thing happens. It tells you that int and strings cannot be plussed together or joined together because they are unsupported. So yeah, going into a bit more of the details of the type system there, that's something that's worth noting. Things like f-strings know how to make numbers and stuff into a string to represent them, but in a more general way using plus or equals or stuff, it doesn't work. So I believe that doesn't work either. It won't convert the 11 into the string 11. Any questions about that? It's another part of Python that's sort of a little bit under the hood. You won't really get to interact with it until you run into a bug with it properly. Yeah, any questions? I'll take that as good. If you do, chuck them in chat. But continuing forward to classes. So this is the last topic that I'll probably be covering. Classes are a little bit different to like Java classes or anything else. They use a few different mechanisms, but under the, basically in the same sort of sense, they're almost the same sort of thing. And having a look at this, this is sort of a very basic structure of a rather simple class. Starts up here. Classes start with the keyword class, much like functions start with def, or an if statement starts with if or while or for. Has some sort of name, which is here, and then is finalized again by another column. Looking at this sort of segment here, we have sort of two sections. We have this def init, which I'll come back to in just a second, and this def hello. And this def init is a little bit weird. This is the constructor, and you might be thinking, why don't they just call it the constructor or the class name, or even something like new? What are these double underscores, and why is it all weird? In short, Python is wibbly wobbly, and you just need to use this one. In long, Python actually creates an object and then initializes the object later, and this initialization is what you use instead of using the underscore new. So if you're going to go program object-oriented Python, the number one thing to remember is don't use underscore new. It is evil. Use underscore init, and that's how you create a constructor. Skimming through, you'll also notice if you're eagle-eyed, this self variable that I've used a lot. And this is because this is how Python sort of establishes the idea of this. If you're coming from Java, JavaScript, I'm not sure if C uses the word this, but I'm pretty sure it does. But this self parameter is basically Python's way of saying this instance. So if we go forward, if we have a look at this instance, and we pass it this hello world, that instance would become this self variable. So yeah, again, if you're saving data between other parts of the class, and as a standard thing in object-oriented programming, you would always just use this self variable. So here we've got this constructor argument. I've just shortened it to con argument. We can see in the self dot variable name, so inside the instance of the class, we set it equal to be the con argument. And down here in this def hello, we can see we print self.varname, which is set up here, and then we return self.varname as well, in case we want to use it anywhere else. So going forwards, instantiating classes into instances is done through a very simple mechanism. There's no new keyword. You just write the class name and then call it like a function. Under the hood, this is just a function, which is interesting to note. This can be overridden as well through some magic, but for the purposes of this sort of walkthrough, this is just all you need to know when it comes to instantiating a new instance of it. So if we do this and then we call instance.hello, what actually happens here is from the start, it will go here, class name hello world. We'll enter this function, self will be the instance, and then this hello world here will equal this con argument, like this. And then that will be saved to self.variable name, or var name. And then going forwards, when we call instance.hello, so that's the saved instance, we call this function. It takes no parameters apart from self. Self is implicit. You don't need to pass it through in either of these. It's a bit tricky to get the hang of. You think, oh, it's got self. You would expect it to, you have to pass through self. But no, you don't need to do that. You just basically, it skips this one in both cases, apart from sometimes. You don't need the return. It's just in this case, I've got it so that it saves it to a variable name, Brian. It's just to show that you can return, basically. You can return different values if you want. But here, we see it uses this self.varname, which is up here. We set before earlier, so this will be self.varname. Here will be hello world. It prints hello world, and then it also returns hello world, so that we can use it here in hello. So I'll do a quick little demo of this, just to show all the different parts, how they work. So class, I'll put a few answers here first. We will just quickly restart shut. And if we go here, and we do. I believe this is camel case. I'm not sure if this is exactly camel case. It's like Pascal case or something. It starts with a capital, and every time you use a different word, you use a new capital instead of an underscore, just by convention. Writing an init, so double underscore, double underscore init, passing in itself, and then we do self or F. Put it up and then so there we are. We just made our first test class, and then we do test one. You can see the Python idle, so the interactive development environment lets us. It shows us that it itself has skipped self, and it only is expecting params. Doing that, we have a test one. We can see it is a test class object. So it's saying it's an instance or an object at this memory location. This is just saying what namespace it's in. So the default entry point for any script or program in Python is underscore underscore main. You'll start seeing a lot more of these underscores when you get to more advanced Python. And if we actually have a look at test 1 and we try, here we go. We run this, we can see it prints out hello world, and if we have a look at variable itself is also hello world. Yeah, so that's a super quick and easy primer to Python classes. Oh, excuse me. You going back to here, you have class, the name of the class, semicolon, and then you just put the functions in using def, level of indentation, underscore init or double underscore init is shorthand for the constructor, and then def hello is just a method on the class. They both start with self, which is implicit. You don't need to put that explicitly. And then any parameters come after it. And then if you want to access this or something else like that, you use this self throughout the thing. Andrew just asked a question. Seems there's no need to declare var name inside the class's member, or does it create one when the object is generated or attached to the variable when the method is called? No need to declare var name inside the class as a member. Okay, so you're saying as if this was something like Java, we would have to do something like this, right? Is that what you mean? Yeah, okay, yeah. No, there's no need to do that. Like everything else in Python, you just declare a variable whenever you need it. This is no different. You can just, on that self, you can just attach a variable whenever you need it. Var name, any other name will work. There's no restriction as long as it's a valid variable. That's a good thing to point out. You don't need to worry about that. So if you come down here and you're like, oh, I need this extra thing, self dot. You don't have to add anything else apart from that line, and it will work completely as expected. So we do that, and we do test 2 equals test class. Even if we do this, this may work. We can see if that's that. And if we do test 2 dot, you can see that that's that. So I can't remember who asked this way ago about the dot notation. Justin, if you're still here, this is where dot notation is used. I've forgotten to put this in the slides, but if you use dots like here for any class variables, such as var name, computed name, or any class methods, that's where you use the dot. Is when you're accessing an attribute or like that, like a method or parameter or anything else like that here. Is the variable passed to the constructor a global variable? No. So if we have a look at test 3, look at this. We look at test. So we're missing test2.varname, so we do test. See that, and we can see that those are different. So they're not global variables. If you wanted to make them global variables, you would have to define them outside. So you'd have to do them at like the script level, which is in this case, if I open something like this, we do this real quick, let me drag this over. If we do, that's how you would get something at a global level. This is purely instance level, so it's whatever instance the class. So if we do something like, if you wanted something at class level, so for all of test, you could do something like this. That would be like your equivalent of static, I believe, in Java, maybe C as well, or C++. That'd be like the static level, and then this would be something like that. I actually don't know if that's going to work. Let's try this. I think I just needed something. I think something. It's been a while since I've wrote a lot of Python like this. Alright, so we're saving on this. So that won't actually update the global level unless we do this. If we have a look now, by adding that global keyword, it now uses this variable from out here instead of assigning it a local level variable. So previously, when we didn't have this global here, if this was gone, this would be, actually internal just to that function. So as soon as that function stopped executing or you finished executing the constructor, that would be deleted. It would have no more references, it'd just be axed. There'd be no reference to it. That's probably a much more in-depth answer than you were expecting for that question. I just realized, but I hope that was useful. Does anyone else have any questions about this? Sort of just blitz through classes, but hopefully that was. Could you add a member using notation like test new? Good question. I actually don't know that off the top of the head. Let's try it. Andrew just asked if we can add new members using notation. So if we try adding this test class, we have test one right here, right? And if we do sum, we'll remember that's something new because we can see it here in this code. And if we actually do test the class name with sum, we'll see that's also that, since we also set it on this line. But if we go test one dot color, I'm pretty sure this will error. Oh no, I'm actually completely wrong. This will not error. So if we look at test one dot color, we can see that will error and I'm completely wrong. But yeah, yes, you can use that. Yeah, just like JS objects. Except you can't do this, I believe. So if you do this, you can't do. That will give you an error. It's a little bit finicky. Classes and functions are the only things you can use this dot notation for. Functions, you don't want to use it in functions, but you can, I think, technically X. Wait, that didn't work. My bad. I keep doing this. I keep jumping the gun. I need to hit enter after X. So we'll go X. You can actually do it there. Don't do it there. That is completely heinous, and will get you into a lot of trouble. But you can. Doesn't mean we have created another definition, another in class. Here. So that's actually a good point. So this test one is an instance of a class. So I'm sort of assuming you have an understanding of object-oriented code, but if you don't, a class is like a template, is the best way to think of it. It's like one template that exists, and then an instance is an actual sort of like object of that class. So if you think about it like a blueprint and like a car, for example, the class is the blueprint. So you have one blueprint of the car, and then the instance is like the actual car. So you might have a blueprint of a Toyota Hilux if you really like utes. And then, so that's your blueprint, your class, just that. And then after that, you'll have an instance, which is, you know, the first car that you make, and the second car that comes to the production line. And those are all different instances, all based off that one blueprint. So test one is just an instance. It's just an actual physical car in this sense. And those dot indentations will only affect that car. But if we wanted to affect all of the cars, so if we wanted to change the blueprint, we're going to do test dot. And if we do that, that will also work. And we have a look at this. And so that will work. And I believe if we do test one dot, this will not be there. Oh, no, that is there. You can see that's there. And if we have a look at, if we make 2 equals test. This is test 2. You can see that that's also there. Even though it's not set anywhere in here, test 2 will also have access to the blueprint since it knows what blueprint it came from, and you can say that that variable is that. I hope that answers your question, Brian. You can do that, and sometimes you can't do that. It depends on exactly how you're doing it. Was that dynamic binding? Yes. I don't know exactly what dynamic binding to class states is, but if it is what I think it is, Andrew. You can just add variables to classes, instances, functions, the global thing, wherever you want. Python allows you to do that. Most of the time, you can do private in Python, but it's not technically private. You can sort of get back into it, but mostly private. I probably won't cover that though. If you're interested in learning about it, it's pretty straightforward. Yes, that is dynamic. Everything will get that once it's updated. So yeah, for everyone else, Andrew H just asked, when I set this test another everywhere, every other class in existence that's already been instantiated or any new one will all have access to it. It's global across all the classes. They'll all get it all at once. Yep. Any other questions? Anything specific to classes? I'm just going to move forward to the last slide. If you have any more questions for anything Python related that we've covered, now would be a good time to ask, but just quickly, I'm going to hand back to Millie.
Awesome. So this is the last workshop/event of Cloud Month, and we will be entering into September. And we will be treating September as our futuristic month. Jackie, let's do the thing. One sec, guys. We're doing a thing. Hey! Can you see? Yeah, we've upgraded, leveled up for futuristic month. And Tom, would you mind showing us the last slide? There's one more.
Sure thing. I will do that just now. There you are.
And our first event for Futuristic Month would be what's next with the Redback bots. I don't know if you guys know or not. Redback bots is our robots, our robotic. Bleh, one second. Word hard. So I don't know if you guys know, we have a team for robotics called the Redback bots, and we actually train them to play soccer, and we compete in the International Robo Cup, where all the universities come with their robots and see who plays soccer the best. And it's a painfully slow competition, but next week we will be teaching you guys how to actually program these bots and make them dance. So make sure to come. There's no registration link currently because we are still figuring out the logistics of time, but somewhere on Monday we will be posting the registration link, and make sure to come to this. We are hosting this paired up with the Center for Industrial AI Research and Innovation Center at RMIT. So there's going to be a few big names coming in to talk to you guys that day. And also we're pairing up with the Programming Club and Switch as well to do this fabulous event. Make sure to come and it'll be worthwhile. So yes, let's step into the futuristic month, people. And yeah, if you have any questions for Tom, ask away. I've said my piece. I'm just gonna chill in the background with this funky thing.
Yeah, futuristic month. So, and also guys, if you can see on the chat, I chucked the link for the Discord and also Facebook. So please follow us for further updates.
Ooh, there's another one I forgot to tell. So we at the GDSC RMIT are actually doing this community project to give back to our society. And what we're mainly doing is, for this semester, an app that helps is not the correct word, battle Zoom fatigue. We're going to build an app to battle Zoom fatigue. So if you want to be a part of this cohort who is going to build this project, make sure to send one of our event managers or even me a message saying you're interested. Tell us your name and your student ID and why you want to join us. Yep. And at the end of this event, you will be getting a post-event survey, so make sure to actually fill in the details there and give us some feedback so we know what to improve and change or whatever for our next events to come. Yes, any more questions for me or Tom? And I don't know if he answered. Andrew asked earlier, is in a iterators like a for in loop?
When was that? Let me just scroll back. What is it?
Like way earlier.
I think I did. Yeah, I think I did answer that. Cheers, Brian. Yeah, if any of you guys have any other questions as well, if you guys want to learn anything else that I haven't covered, if you want me to show you some fancy things you can do in Python, like generators or list comprehensions, or you want to learn anything cool, or if there's anything you're still confused about, feel free to ask. Otherwise, I'm just going to start writing random bits of Python, hoping I'll get people's interest. Yeah. No worries. Thank you to Andrew for coming along. Hope you have a great time as well. Brian, yeah. Good question, Brian. Okay, so you're going to learn some advanced Python. Some really cool things. There's this one called List Comprehensions. It's my dad's favorite Python thing. It goes something like this. So let's say we have a list.
We can't see your screen if you're like doing the thingies.
Thanks. I will. Oops, wait. I need to do an entire screen. Let me do this. There we go. Thank you. All right, there we go. So this is coming up. So let's say we have a list of numbers 1, 2, 3, 4, 5. And let's say you want to get the square of each number. A typical way to do that is for you do something like this new, a new empty list. Then you do something like for the number in numbers. And you do new. I forgot to mention this, but append is how you add something on the end of a list. Number to the power of 2n. And then you do that, and then you can see print. If you look at new numbers, we can see that's the squares. Another way you can do this is if we have a look back at the old ones, is through this thing called the list comprehension. This follows the syntax of value and for new for old in something like that. And if we write this inside a set of square brackets, like you would in an array, and we do something like number for num, character for num, with numbers. If we do this, you can see it actually does that whole calculation, that whole for loop that we'd written before, one line. Which is something that's great about Python. You can do a lot of things in one line in Python. So just showing this, you can also do, I know, it's pretty good. You can do some really cool things. Sometimes you can have like 5 of them nested in one spot, and that is crazy. That is, anyone who does that is a magician. But you can do some really powerful things with it as well. Num in numbers. So let's say num is, I've got to show the modulo operator, but that. So this is just saying, that's just the modulo operator. So if I do name, let's get another one up here just to show. Let's do 10. Let's do 11. Print. Look at that. This is just the modulo, so it's like, you know, even, odd, even, and it shows the remainder. So we do something like this, we can see that it's only going to give us the squares of numbers if that number was originally even. So you can add conditionals in here. You can do all sorts of things in there. I've forgotten exactly the right way how to do it, but if you had nested numbers, so if you have, let's try this, 1, 2, 3. This, you can do something like value for value in sub in the right way around. Let's try this. Well, you can do nested ones. What if you wanted to square all the even but still print all the odds in your example before? That's a good one. So this is bad, but going back to this one, you can actually chuck an else statement. Oops, I forgot. Do it right. Do it. One second, I need to Google search this one, but I know you can do it. Let me just give me a sec. Python. You do it like this. Cut that if at the front. One second, just forgot the else. There you are. So that's how you do it, right? It's a little bit of trial and error, but basically is value if condition else value for num in number. Yeah. So you can do a lot of really weird and whack things and wonderful things in this. So if you have a look at this one from before as well, where is it? Here you are. Yep. So this one is actually like 2 loops. So this one has the first loop for sub and nested. So nested is our nested list, and this will get the sub list. So this will be 1 or 2, or 3 or 4. And then it gets the individual value out and actually stores that one in the new list. Yeah, basically like that. You're just writing the whole thing into one line. It's crazy. You can do the same thing for dictionaries, which is absolutely batshit bonkers. I love it. So if we have a look at this, if we do, let's just quickly, let's grab this one just to show you this. Whoops. So that gives us an object. If we do this, list is the actual long way to make a list, and it can do that from iterable. So we see this, enumerate gives us the index and then the value, index value, so on and so on. What we can actually do is we can do a dictionary comprehension as well, which is a similar sort of thing, but we can do str turns something into a string, so key value or key value in. And you can see here we've done that exact same thing where we've got a string, the key and a value, like for a dictionary, from this list, which is 0, 1, 1, 4, 2, 9, 3, 16, 4, 25. So yeah, there, again, more weird and wonderful things. You can also do this for sets, which is like a dictionary but without a key or value, it's just the value. And all sorts of other weird things. You can do the same things here with the if and the else statement, the keys. Crazy. I hope I've expanded your mind to the possibilities of things you can do in Python. Probably a lot of it just went right over the top of your head. If you're not very familiar with the syntax or you can't read it, which to be fair, I think I was doing that mostly by muscle memory, so I don't really know what I've done. But yeah, there's it's really worth looking into list comprehensions, dictionary comprehensions, all sorts of things like that if you're interested in writing really confusing but wizard grade Python. Yeah. Anyone else want to see other things? I've sort of skimmed over like type conversions and a whole bunch of other things. I figure they're probably a very easy Google search away, so I've sort of covered a bit more of the broad strokes of things like classes and functions. One thing I might show for everyone still here is, since Python doesn't have the concept of, are there any frameworks you like to work with in Python? So Justin's just asked me if there's anything I like to work with Python. Yes, the standard library is number one. The standard library in Python is amazing. It is the best thing in existence. You can pretty much use any sort of thing coming out of that. But as for frameworks, I do a lot of web stuff. So I work at Lidl, so I'm currently doing web system with REST. And that's a lot of my personal projects have been like web systems with web servers and REST frameworks and stuff like that. So the one I use pretty much consistently all the time is called Flask. Let me bring that up. It's just spelled like hit Flask, like Flask. There we are. After all the ads, you can see here Flask. If we have a look at the quick start, this is a super easy way to write web servers, and it's even easier because it's made in Python. But it's really straightforward. If you have a understanding of web servers, like here's a route, here's how you get HTML comes out of it. It's literally 1, 2, 3, 4, 5 lines to get a fully fledged, almost production ready web server running in your Python, in Python. 5 lines. 6 if you count, 6, 7, 8 if you count installing and setting and actually running it. I think that's a pretty good bet is 8 lines to run a full web server in Python. Other things, there's a lot of really, really good libraries for Python. So there's one called Requests for making HTML requests. There's a really good one called Pillow. I think it's PIL in Python 3 for image manipulation. So if you want to go through pixel by pixel in images or apply filters to images or anything like that, Pillow is really good. And then I don't touch it too much, but there's a huge amount for machine learning. So there's like scikit-learn, there's TensorFlow, there's all sorts of really, really good stuff. Yeah, I hope that's sort of giving you a sort of broad depth of what you can do with Python. Any other questions? All good if there isn't. Might give. Yeah, I would definitely suggest, if you want to, a really good thing to do is probably make a little like to-do list app. I know they're very cliche, but make a to-do list app with a spin. So maybe make a to-do list app that randomly deletes tasks if you don't get them done quick enough, or you have to like double check, like check it every 10 seconds, otherwise it sort of jumbles up your order or like does all sorts of weird things. Just make something fun that sort of stands out, but it's still easy enough that you can put on your GitHub or resume, and you can show people, oh look, I've done this thing. It's quirky, you know, it's a to-do app under the hood, but it's cool, it's fresh. I'd suggest doing that. Really easy, good way to learn databasing as well. Chuck in Mongo, SQL, really, really good starter stuff. I reckon you could probably also join in with GDSC and help them on their app for Zoom fatigue, because I have a feeling that they could be using Flask under the hood as well.
Yes, we might be. Because I've been using Flask for basically everything these days, so there's a high chance of that happening.
Flask is really good. Yeah, I hope that I hope that explains a little bit more to you. Any other questions? If not, I may quickly jump onto something else, which I didn't cover. But in short, Python doesn't have a concept of types, which means you can't do operator overloading. So in something like Java, you would do something like x, you know, right? Well, I don't know exactly, and then and then you might have def x string number. And they'd be different functions, right? In Python 1, I can't do that because there's no such thing as number and string like that. That would give me an error. But what you can do, excuse me, what you can do is you can use the type function. If type of param is string, str is short for string. I'm gonna do this. I'm gonna do like this. You can see 1, 2, 3 is a string in this case, which is not a very good example for a string. But if we take away these quotes, you can see now that it is not a string. So that's how you would generally handle in Java how to deal with something that is like operator overloading. Python, you just handle it at runtime. Technically, a little bit more overhead. Not really. Python's written in C under the hood, so it's still pretty fast to do all these type checks and stuff. A little bit more, not too much though. Another thing Python also has in terms of function parameters is this concept of args and keyword args. Django? I haven't touched Django actually, Pamel. This is sidetracked from this again. Pamela just asked my thoughts on Django. I haven't written in Django. Comparing it to Flask, it's sort of like it does everything. It has an ORM. It has a whole bunch of really cool things. Super powerful again. Really good. But on the other side of the fence, there's Flask, which is like, really lightweight. It doesn't ship with too much. It's just a web server, and that's pretty much it. And depending on which way you like to go, if Django has all the things you want it to do, then by all means use Django. It's probably quicker than having to set it all up in Flask. But if you need to do bare bones sort of stuff, or you need to use something that Django doesn't have, odds are Flask is probably easier to integrate it with. And it again just boils down to personal choice. I don't really have too much of a strong opinion, but I prefer Flask. But yeah, that's a good question, Kamal. Web servers and stuff in Python are pretty popular, especially with cloud. It's really, really cheap to get a lot of grunt out when you need it, especially when you need it in cloud. So it is, Python's just super worth it for the pure speed of development. Any other questions? I made a little bit of a test function here. This is going back to the point that I was just talking about just before. Python has this concept called Args and keyword Args, or quags, as they're affectionately known. And I have demonstrated this here with just this star and this double star. Basically, what that allows us to do is if we do this testing function, and we do, you can see here they're listed there, and we just do 1, 2, 3 as in the first arg. We can see it prints here. But the funny thing is, we get these two things. This is a tuple. So I didn't explain this very well in Python before as well, but like you can put whatever you want inside a tuple, and it's basically just a static list. You can't grow it, you can't shrink it, you can't edit it. It's just a set of these items, and they won't change except internally, but that's a different story. So that's what a tuple is. So you can see here, it's actually giving me an empty tuple, and down here it's giving me an empty dictionary. And what this allows us to do is if we give it, if we call testing function again, with these things, so it's like this function, we can see that all of these extra things that we would normally have as an overflow actually get put into this tuple. So you can use those things in your code. You can just call them like args 0, args 1, whatever, extract them out. So if we rewrite this function, this will not always work, but for the case of a demo, it will. I'll do that. We can see it prints those two out, which is pretty nifty. I'm just going to bring back the original one again, just to show what that looks like. Again, I've just written this one before, but it also allows us to use this thing called keyword arguments. So if we keep these here, we can do something like this. If we have a look here, these names in these keyword arguments using this equal sign will get put into this dictionary, this keyword arguments. And then you can just access that like a dictionary that we showed before. So if I go all the way back in here, and we go, where's dictionary? Here we are. And you know how we access dictionary like this? You can do that exact thing. Oh, that's the wrong one. You can do that exact thing just by using that double star, and it automatically turns anything with the name equals whatever values into a dictionary for you to use. So it's really good. Yeah, exactly. Yeah. Brian, you're right on the money there. It allows you to expand or shrink things into those sort of data types. Really, really powerful. So, a really interesting point to make. I do not believe there is a triple star. I would not know what that would do, Brian. But that is that's an interesting question. I like your thinking. If we have a look actually at, there's a help function in Python as well, which allows you to look at the documentation for functions. If we actually have a look at the help of print, you'll notice I did this earlier, and I sort of skimmed straight by it. Because if we have a look at print, we can see here that it has this value, and then it has this ellipses. And what that ellipses is exactly like this star args. And what happens is it means it takes a value, but if you do comma and then another value, comma and another value, or infinite times, it will just print them all together. And it will use a separator, which is this separator, and this end file, this end line to, again, separate it and put this at the end. So if we do something like this, print, oops, bit ready on the enter. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, oops, like that. Oh, print them all like that. And then if we do something like this, set, there's that set window, we put something like this in, we can see. Oh, and again, it takes that keyword argument in, which was set to a default actually before, which is something else I can talk about, but I probably won't. And changes it so it does that. And then if we go and do this end as well, and we do that, you can see it gives me a whole bunch of new lines at the end. So that's a really powerful way to supercharge your functions, add in optional things with keywords, and you can just check if they're in the dictionary. If they're not, then you don't have to worry about it. But if they are, then you can do some sort of behavior. Allows you to have huge arrays that you don't actually need a huge array for, and just handle any arbitrary number of arguments. That's one of my favorite things in Python. I think that is an absolute wonderful thing that it's done. But yeah. Yes. So sys is the standard library. Yeah. One of the standard libraries. Good spot there, actually. So you can change that. We can actually, yeah, we can change that so it does a read and write to a file. Probably a bit late to show it now, but if I do an intermediate Python, maybe somewhere down the line, I will definitely make sure to mention that. Yeah. Yeah, you can definitely learn all of these things. Again, I didn't actually know about the file sys.out, but I've now learned about it. You can do a lot of really, really cool things in Python. Final thoughts? Any final questions? If you want to learn this all yourself, there's tons of free resources online. Definitely suggest looking at all of them. If there's one to remember, it's called Learn Python the Hard Way. Bit of a scary name, but the best resource there is. Yeah, I think that pretty much ends that. Any other questions? Anything else anyone wants to talk about?
I must say, this has been quite a wonderful workshop. Thank you, Tom. Yay!
Yeah, thank you everyone else for coming as well. It's great that you all came along. I hope you got a lot out of it. I didn't show anyone. I forgot to show everyone anti-gravity. Damn it. Oh, I missed that. Anyway, and we do import anti-gravity. Watch this. Boom. Oh, come on. Shell. Restart shell. Here we go. Now it'll work. Boom. There we are. Look at that. Hope everyone has a good Friday night now, that they've done some extreme learning.
True.
This goes at the end of the highlight clips. funny bloopers.